Let's say you came across this question in your chemistry exam. How will you solve it? It is very easy. Now let's solve together. The question says, in the equation above, I believe you can see the equation on the board. Listen properly. The question now says, listen, the equilibrium constant is given by, now listen and listen well. This question is extremely very easy. You know, before you solve any question in chemistry, it is very vital for you to know the topic to which that particular question is from. And from the look of things, this question on the board is from a very vital aspect in chemistry called, listen, called chemical equilibrium. Listen and listen properly. This topic is from a very important aspect in chemistry called chemical equilibrium. So how do we solve this question? It is extremely very easy. I already have a full video lesson on my YouTube channel that explains properly on this topic from the scratch. So it is very important for you to go watch that lesson on my YouTube channel. After learning how to solve questions like this on this aspect, because at the end of solving this question, I'm going to give you your own practice question so you solve and provide the answer in the comment section. So listen and listen well. So the question says, listen, it says, the equilibrium constant is given by, now let me tell you something very important. Actually, they can either say the equilibrium constant is given by, or they say the equilibrium constant expression is given by, because it is actually an expression. Listen and listen well. Note this. Equilibrium constant in this aspect of chemistry called chemical equilibrium is symbolized as, first you must know the symbol to which equilibrium constant is given. And what is the symbol? Listen, equilibrium constant for any kind of reaction is given by a symbol, and that symbol is K. Now listen, I can decide to add something. It can be given as K, or I simply say KEQ. Please listen. This EQ simply means equilibrium. Are you there? EQ, equilibrium. But we can simply just, say K or KEQ. Are you listening? Not these things. So now you can either use any of them, but let me just use one in this case. Let's use the first one written, which is what? K. Now listen and listen well. This equilibrium constant, which is symbolized as K, can be in two forms. Listen and listen well. What did I just say? I said that equilibrium constant, which is symbolized as K, can be expressed in two forms. What are these forms? Listen and listen well. One of the forms is when I write K and put C down. I'm going to tell you what this means. And also when I write K and put P down, I'm going to tell you what this means as well. In my full video lesson on the topic chemical equilibrium, I exhaustively explained everything you must know about chemical equilibrium from the scratch up till mastering that lesson. I solved so many questions dealing with so many principles in that topic, like the Le Chatelier's principle, where I made it so easy. So ensure you go watch that lesson on my YouTube channel. Are you there? So let's get back into this question. I just explained to you that this K, which is equilibrium constant, can be expressed in two forms. What are these forms? Kc and also Kp. Now, what does Kc means? Listen. Kc simply means equilibrium constant. K is equilibrium constant, but the C there means concentration. Listen, what does that C mean? Concentration. So adding the word concentration to what K is, which is equilibrium constant, Kc becomes equilibrium constant written in terms of concentration. Kc is simply equilibrium constant written in terms of what? Concentration. Because I told you already that the C simply means concentration. Are you there? Whereby this P here simply means partial pressure. I did not say pressure. I said partial pressure. So adding them together, Kp becomes equilibrium constant expression written in terms of partial pressure. Don't worry, go watch my full video lesson on this aspect so you understand all you have to know about chemical equilibrium. All right. Now, how do I know which of them to write for? Which of them to actually express in this question? It is very easy. Now, listen and listen. From the word equilibrium constant expression written in terms of partial pressure, it has to do with the substances in that equation or reaction to be in gaseous state. Now, listen and listen well. If you observe, this is not a standard reaction. This is just a reaction where they use letters, but there are principles and things to note whenever you're writing equilibrium constant expression, either for concentration or partial pressure. Now, I will tell you what to note, so you just listen and listen well. Now, I'm going to tell you the one to write for in this question, because all my options, I saw something very important there that tells me exactly the one to write for. Though, to write for both of them, you apply the same rules. Listen, guys, listen. Now, let me tell you something. In chemistry, whenever I see this symbol, which is bracket, in chemistry, it simply means concentration. What did I just say? In chemistry, this bracket simply means concentration. So, me saying that all my options, I'm seeing this, it simply tells me that the K they want me to write for is actually KC and not KP. If it was KP, I will know. So go watch my full video lesson so as to learn how to write for KP, guys. They are all very easy. Alright, guys. So listen and listen well. Alright. Okay, guys. Let's get into this question. But before I solve this question, before I tell you what to do, please listen. To write for equilibrium constant expression, either in terms of concentration or in terms of partial pressure, there is something you must know. Alright. In the expression, listen and listen well. In the expression, there are certain type of substances that are not supposed to be inside the expression. Now listen, whereby there are certain kind of substances that is supposed to be written inside the expression. Now let me tell you what to note. Listen and listen well. Listen to this. Class, listen. Gases, substances that are gases or substances that are aqueous. When a substance is aqueous, it simply means that that substance has been dissolved in water. So listen, gases and aqueous species, any substance that is a gas or aqueous species, they do appear in the expression. But any substance that is liquid or solid, listen, any substance that is liquid or solid, they don't appear in the expression. We don't write them in the expression. This is because solids and liquid are taken to be one. But just note it, guys. Solids and liquid, they don't appear in the expression. But looking at this reaction on the board, they did not tell us if any of them are gases or liquids or solids. So we just write for all of them because we're not told what state of matter were the substances involved in the reaction. But don't worry, after solving this, I'm going to give us more practice examples so we get to see what I'm talking about. So listen and listen well. There is a formula to note. Listen, let me tell you. So we have agreed now that we are writing for what? Kc. Now let me tell you the formula. The formula to write for Kc or even Kp is this. You simply say product. Listen and listen well. Product divided by reactant. Remember, in a reaction, we have how many sides? Two sides. We have the right-hand side of a reaction, which is the product side. So this is my product side. And we have the left-hand side of a reaction, which is the reactant side, all right? So this is the reactant side, whereby this is the product side. So, see, do this what you do. Listen and listen well. You now write Kc will now be equal to, let me tell you guys, very easy. The elements or compounds that are in the product and the reactant, you start identifying them. Now listen and listen well. So I have two important substances in my product, and what are they? They are substance G and substance H. These things that are attached, they are the mole ratio. You know, in a standard chemical reaction, these elements, they have numbers standing in front of them. Those numbers are the mole ratios. Class, listen, I believe you know what I'm talking about. Like, for instance, listen, let's say hydrogen gas, all right, is a gas reacting with, oxygen gas, all right, to form water. Class, which is what? H2O. Let us balance the reaction. What do? We have You know, we have one oxygen in our right hand side. So to balance it, because we have two in our left. So to balance the oxygen, I simply put two here. Are you there? So oxygen now is now balanced because I have two in my right. Two, because you know the number standing in front of these compounds or elements will times everything. So two as times oxygen, so making it oxygen in my right and two oxygen in my left hand side, whereby for the hydrogen in my right it becomes 4 because 2 times 2, that is 4, whereby I'm going to add 2 in front. Are you there? You can see the 2 I've added. So 2 times 2, 4 hydrogen in my left and 4 hydrogen in my right. So reaction is balanced. So these letters you are seeing standing in front of these substances or elements, they are not like standard elements. I just call them substances. They stand as these mole ratios, the numbers standing in front of these elements and compounds. Are you guys listening? Please listen and listen well. So let me teach you how it works. Listen. At the end of solving this question, I'm going to give you on. So pay attention, guys. So now we simply now go to our product. What are the substances G and H? I will pick one of them first. I have 2. I'll pick one. The first one I have is G. Alright, so case one for my product. So G. Since my options are expressed these guys in a bracket, so it tells me that it's actually KC I'm writing for. So if I'm writing for KC, all the elements should be inside the bracket, guys. So this should be inside the bracket. Are you following me? Because KC simply means equilibrium constant, written in terms of concentration. And concentration in chemistry simply means this bracket you are seeing here. Are you there? So you can see we've written for one of the substances. Now let me tell you, the number or the alphabet standing in front of that substance should be raised as the power. That's how it works, guys. All of this was extracted from the law of mass action. Guys, listen. All right. So let me tell you, because if it was to be a standard reaction like this, it would have been a number standing in front. So numbers or alphabets standing in front of the substance should be raised as the power. So now P standing in front of G, so P should be raised as the power. So now me going to the next element, which is H, I will times, guys, that's how it works. I will times, I will not plus. This dot means times in this aspect of chem. You know, dot in math is times. Hope you know now. So times H. Still put it inside a bracket, and what is standing in front of it, which is the coefficient, it should be raised as a power. And what is that? Q. Listen, so Q. So we are done writing for our product. Let's say, for instance, we have another plus something. We will now take times and continue. Are you following me? So we are done divided by reactants. And what are my reactants? Here are the reactants, E and F. So first I write for E. So E, open bracket, close bracket, M, always about M. I've said that already. Times F. Alright, open bracket, close bracket, all raised to the power of what? N. Class, are you there? Class, this done is the equilibrium constant expression for this reaction. It is very, very easy, class. It is not difficult at all. You can see how questions on this aspect have been tackled without stress. I'm going to give you a practice question and you solve it and provide the answer in the comment section. Whether I'll solve another, I'll give you your own, so as to just run through all of these aspects. But ensure you go watch my full video lesson, because there are still more things to learn on the aspect of chemistry called chemical equilibrium. So what becomes the answer to this question? The answer becomes option C, because option C corresponded to what we got. All right, so all these are easy. Let me give you one practice question you solve, and I'm going to solve another, just so that I run through all of this approach. All right, they're all very easy. All right, guys, let's get into the next practice question. I'll be solving this, then you solve this. All right, so this is your own practice question, so listen and listen well. Now the question is, provide the Kc, which is equilibrium constant expression written in terms of concentration for this reaction. I'll be doing this. So Kc now becomes, you know, already is product of a reactant. You know, I told you, if they give you a standard reaction, you must check first. So know exactly this kind of substances you were given, all right? You check. If you have solids and liquid, remember I told you that they don't appear. So when I say solid, I'll cancel solid. Oh, I saw solid. Carbon is a solid. Wow, I'm going to cancel it out. Are you there? Class, listen. So, oxygen is a gas in this case. CO2 is a gas, so I'll leave those guys because they appear. Gases and aqueous, they appear. Whereby, okay, you do this one. So since this guy definitely is a solid, I'm going to cancel it out and write for what is remaining. And the formula is already what? Product divided by what? Reactant. Whereby Kc will now be product. This is my product. This is my product. You know, normally the reaction should be balanced. The reaction is balanced. Okay, if you don't know this in chemistry, listen. If you don't, because the reaction is balanced, but if you don't have any number standing in front of any compounds or element in a reaction, you just assume it to be 1. There is an invisible 1 here as well. Let's check together. How many carbon do we have in our left hand side? 1. How many do we have here? 1. Carbon is balanced. How many oxygen do we have in our left? 2. How many oxygen do we have in our right? 2, so it's balanced. Same applies to this. This one basically should be also 1 as well. Because 1 times 2 is same as 2. It's like you writing nothing, but in this expression, it is vital. You just note the powers. Because you can use it in a very vital aspect in chemistry called rate of a chemical reaction when you're calculating for what is called order of a reaction. So listen and listen well, guys. I'm not talking about rate of a chemical reaction right now. I'm focusing on how you can basically write the Kc and Kp for reactions in the topic chemical equilibrium. So guys, listen and listen well. This reaction is also balanced. The down one is balanced. Let's write. So product, this is my product. So first the CO2 is my product. Ensure since you write for Kc, put it in a bracket. For Kp, go and learn how it's done in my video lesson, alright? So, see, the coefficient standing in front of that particular compound or element should be raised as a power. Or raised to the power 1. Do you understand? Divided by reactant. And I only have, initially I had 2 because carbon is a solid. I will not add carbon. Are you there? I'm just going to write for oxygen gas. So, oxygen gas, please just write for the guy. Don't write the thing. Don't write the number standing in front inside the bracket. Don't do that. Ensure the number standing in front of the compound or element should be raised as a power. So what's the number standing in front? 1. Class, I am done. This is the answer. This is the equilibrium constant expression written in terms of concentration expression for this equation. It is very easy. So guys, this is your practice question. Look at it properly and provide the Kc for this reaction. We've come to the end of this video lesson. If you find my video lesson helpful, make sure you click on the subscribe button to my YouTube channel and also share my lessons with your friends. Thanks for watching.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.